Welcome. It has just gone 7 p.m. Eastern Standard Time, Wednesday the 15th of May, and you are watching episode 132 of Regional Wrap. Regional Wrap providing an insight on the issues affecting regional Australia and giving a voice to regional residents. My name is Bill Bates, and joining me on this episode, Climate, it is etched in stone, is my guest, Professor Ian Plimer. Ian is Emeritus Professor of Earth and Science at the University of Melbourne, where he was a professor and head of Earth Sciences from 1991 to 2005. Ian grew up in Sydney and attended the Normanhurst Boys' School. He earned a Bachelor of Science in Mining Engineering at the University of New South Wales and gained his PhD in Geology at Macquarie University. Ian has also been on staff at the Universities of New England and New South Wales. He has published more than 130 scientific papers on geology and was one of the Trinity editors of the 5-volume Encyclopedia of Geology. Ian has published 15 books for the general public. The best known is Telling Lies for God. He is a frequent contributor to newspapers and magazines, opinion pieces, and is a regular broadcaster. Ian has been a director of numerous mineral companies, the president of the Geological Society of Australia, president of the International Association of Genesis of Ore Deposits, president of the Australian Geoscience Council, and sat on the Earth Science Committee of the Australian Research Council for many years. Ian is currently the non-executive director of unlisted companies in the Hancock Prospecting Group, including Roy Hill Holdings and Atlas Iron. Ian is the patron of Lifeline Broken Hill, the Broken Hill Geocentre, the Mineralogical Society of Victoria, and the Mineralogical Society of Broken Hill. Welcome, Ian. How do you find the time to do all these things?
Well, I've always been flat out in my life. I'm still flat out, but I'm very well organised with my time, and I use blocks of time for work, for relaxing, for being with friends, and I'm often up your way to actually see friends. I quite often go up to Chillago to catch up with a good mate of mine up there, and when the mines are operating there, the Red Dome mine, I used to go up there quite a bit. And in the late 60s, early 70s, I lived in Dimbula and worked at the Wolfram Camp mine. And it was all of the work that I did on that fascinating mineral deposit that led to my PhD. So I use my time wisely, I think is the best way.
Well, you're probably more organised than myself. The conversation really centres around people's perception and knowledge of the climate, and we seem to be focused, especially through the media and that, on climate models and computer models and things like that. But it's like many things, the actual hard science and the actual science which involve field work, like even when you're talking about Vegetation Management Acts, things like that, you have people have work histories of 40 odd years out in the field doing the work, people like Bill Woodward. But when it comes to government policy, they seem to always refer to the experts, academic experts in that, and they sort of diss the people who have a wealth of practical experience. Is that a phenomenon that's only just occurred in, say, the last 20 years?
I think it is. We have a huge problem in this country, and it's a division between those people living in the cities, especially the coastal fringe from Cairns down to, well, where I am at present in Adelaide. And these people never get inland. They're the bulk of the electorate. The politicians have to listen to them because they're the numbers. And then we have bloated public services. We have a bloated public service in Canberra and state public services. And this means that we have people who are basically looking at surviving and staying in their job rather than looking at the wealth of the nation, rather than looking at the health of the nation, rather than trying to grow the nation into a stronger and bigger and better nation. So if you want to get a solution to a problem, then people use models. Now, models are a very naive way of trying to understand how the planet works. And mostly they're wrong. They're just an attempt to get an understanding. The only way to get an understanding of how the planet works is to get out there and observe, to measure, to do experiments, and to do them time and time and time again, and to put together a history of, be it the vegetation, be it of animal life, be it of the geological time, because it's the past that tells us about the present and the future. It's not a model. And when it comes to climate models, then we've got more than 100 climate models, which we've had for more than 30 years. These models are predicting we're going to fry and die. We've had 30 years of measurements to show whether that's going to happen or not. And we can show that the models grossly overheat. We can show that the models are demonstrably wrong. And we can show that climate in the past, and there's no reason why it should be different in the present, that climate is cyclical. And these cycles are based on long cycles, which are based on whether the continents are pulling apart or stitching back together again. They're based on where we are in the galaxy. They're based on the Earth's orbit. They're based on the variations in radiation coming out from the sun. They're based on lunar tidal processes. And we have long-term records of measurements and proxies where we can work out that we've had these massive cyclical changes of climate. And just because you're living on the planet today doesn't mean that climate change is a result of anything you do in today. So what we're having is people that don't know history, they don't know about the past, and they're saying in some great fit of narcissism that something that happens today is obviously due to what I do. Now, that's just ridiculous.
Well, I suppose the thing is, it's probably a bit of a ego thing. Is man is everything to the earth. You know, we know all and we do all, and then obviously we must change all. But we also seem to, the media and everyone who pushes the narrative, they don't even reflect on basic things like we've only been a civilized mob for probably about 10,000 years or even less. We've only got written records going back maybe 3,000 years. They're a bit sketchy. Probably one of the best groups that provided records was the Romans. And we've got records about Britain being warmer during the time that they were occupied. So why do scientists seem to so readily dismiss things that have been documented in even in recent history? I understand it's difficult the further you go back in regards to human records, and that's when you've got to go over to geological records for a lot of information. But we seem to even diss those sort of records that are recent and reliable as well.
Well, the media is not interested in the truth. The media is only interested in sensation. That sells. And if you have a media story that is telling you the truth, which is generally a little bit slow and boring, then people change channels or don't read the newspaper, and the journalists are out of work. The second thing is the journalists are almost to a person completely and absolutely illiterate, and they are unable to ask the simple questions. Now, the scientific knowledge that a journalist has is very close to zero. I would regard them as being scientifically illiterate. I would regard them as being equivalent to a person who can't read or write. So here they are, unable to deal with simple science. They should know history. And we know from history that it was warm in Minoan times, and then it cooled down. Then it was warm in Roman times. And we know it was warm. It was not only the clothing they were wearing, but where they grew their crops. They grew olives right up the Rhine as far as Bonn. They had grapes in Yorkshire, in northern England, that they used for making wine. They're good indicators that it was warm. They kept good records of their grape harvests and their salt harvests. So we've got a pretty good record of it being warm in Roman times, and then it cooled down. and we entered the Dark Ages. And the records there are not as good because the Dark Ages were times of hunger and starvation and warfare and depopulation. Keeping records was one of the last things on people's minds. It was survival. And then we came out of that into medieval warming, where again we have good records. And we have records of harvest. We have records of 2 harvests every year. And there was so much money generated in those times that we could build the great monasteries and cathedrals and universities in Europe that people visit. And we know that it was much, much warmer than now. That's just from history. And then it took 23 years to cool down into the Little Ice Age. And we know again, and the records are a bit better, from harvests, from paintings of hoarfrosts, from records of frozen rivers and canals, where in fact on the Thames you could barbecue oxen. The ice was so thick. And we came out of that Little Ice Age about 1850. Now, we've been warming since the Little Ice Age. What do you think is going to happen after Little Ice Age? We're going to get cooler or we're going to get warmer? So we've got very good historical records. We also have very good chemical records, because any floating organism, which when it dies will end up in muds on the sea floor or a lake floor, gives us a very good record of what the air temperature was. And we can do that from the chemistry of that little floating critter. And so by looking at the shells of these floating critters, we're able to plot temperatures going up and down all the time. We're able to plot sea levels changing. We're able to plot current activity. So we have extremely good proxies that go way back. We also have good proxies of when the sun starts to pump out more or less energy, because that then creates radioactive chemicals in soils and on the surface. And those are preserved for a period of time, and we can measure those, and we can back calculate and tell what the sun was doing. We have records, very good records, from other chemicals in the rocks. We've got good records that people use, say, for finding petroleum or coal, of where the sea shore was, what sea level was doing. And for 80% of time, sea level was higher than now. For 80% of time, it was warmer than now, and it was wetter than now. We're living in a period when there is ice on the planet. Now, ice has been on the planet for less than 20% of time. We are currently in one of the 6 great ice ages that the planet has seen. And these are cyclical. Now, these cycles occur with great regularity, where we've got measurements of these cycles, measuring the distance we are from the sun. So if we're close to the sun, we warm up. If we're further away from the sun, we cool down. And these cycles are on 20,000, 40,000, 100,000 year cycles. Now, the current cycle we're in is a 100,000 year cycle, and 10,000 of those are warm and 90,000 are cold. We're at the end of a 10,000 year warm cycle, we're coming back into a glacial cycle. Now, that's happened hundreds of times in the past. There's no reason why it's not going to happen again. So we have extremely good information to show that climate is cyclical, and that this climate cannot be driven by a trace gas in the atmosphere, which is carbon dioxide. Now, currently, carbon dioxide in the atmosphere is 0.04%. In the past, carbon dioxide in the atmosphere has been up to 20%. Now, we didn't have runaway global warming then. We actually had ice ages. We had 3 of the greatest ice ages ever on the history of the planet, was when the carbon dioxide content was far, far higher than now. Ice was kilometres thick at sea level at the equator. So you've only got to look back in the past and say, well, wait a minute. Climate has been driven by that great ball of heat in the sky called the sun. And we have cycles, whether we're closer or further from the sun, and the sun pumps out variable amounts of energy. All the other cycles are minor, and we certainly don't see in geological time that carbon dioxide has anything to do with climate. The first 100 parts per million of carbon dioxide in the atmosphere keeps us a little bit warm, and after that, the effect is negligible. So we have been fed a story that is totally and absolutely not in accord with what has taken hundreds of years to establish. And this is why I call out the climate sect. It is a cult, and the science that they're pushing is science which should be taught in the schools, but it isn't. So it's very easy to con the whole community if you've got ignorant journalists and if you've got kids who haven't learnt the basics of science at school. It would help to learn a bit of history. It would help to learn a little bit of geology.
Well, I remember as a kid we touched on geology. We learned a few different types of rocks. Igneous rock seems to stick in my head for some reason. But it was fairly minor. But one of the things we did get a look at was geological timescales. And I'll just flick a screen share up now. This one's a fairly simple one. Of course, where we are today, we've got the different eras and that. But it's quite amazing that we can get to a system of where almost an era or a time period, a subdivision, it is broken down to so many levels. I mean, gee whiz, people must have took a lot of time and a lot of effort to get all those individual categories and identify those different changes.
Yes, well, this has taken a long time. Geologists in the past were fascinated with fossils, and that goes right back to Greek times where people were fascinated with fossils. And there was a time in the Industrial Revolution in England where there was to be a construction of canals and railway systems. And to do that, you needed to have a reasonably good idea of what the rocks you're going to be quarrying for that canal or for that railway cutting. And you needed to be able to predict what was going to be ahead of you, to be able to predict how much material you had to quarry to get out to create that railway cutting. And people started to use fossils for that. And there was a geological map by William Smith put together of England showing the particular rock types. And that was based on fossils. And people have been collecting fossils for a long while. And the way we've been able to divide geological time based on fossils, and that's only for 20% of geological time, the rest of the time we haven't had fossils with skeletons or with shells. But for that 20% of time, we've actually looked at when fossils appear in the geological record and when they disappear. And these are major catastrophic events. And we've got 5 major mass extinctions of life and 23 minor mass extinctions of life. And this is when you wipe out large amounts of life. And normally that's by some extraterrestrial or volcanic process. It's never been by climate. And so that geological timescale has been put together by looking at what fossils are preserved. We get an idea in that sedimentary record of what has been the previous climates, because we look at what's been left behind by glaciers. And we see periods when the whole planet was covered in ice. We also, from that, get an idea of, by looking at a sequence from gravels up to sands, up to silts, up to muds, we can work out whether sea level was rising or whether sea level was falling. And this has been used by petroleum geologists for 100 years to work out where the best rocks are for the formation of petroleum, which then later moves and concentrates in rocks. So you might have got interested in remember the igneous rocks, but the sedimentary rocks and the fossil-bearing sedimentary rocks are the key to past climates and past life. Now, when we go earlier back in time, we do see things in very ancient rocks. I've seen in rocks that are billions of years old. I've seen ripple marks. I've seen salt casts. I've seen raindrop marks. You can clearly see, if you've got that sort of material, that it was exposed to the air. This must have been tidal. We can also see deep water sediments. We can see material left behind by glaciers. We can see material that were deep sea muds that have had icebergs floating out, melting, and then dropping material into the sea floor. So even without fossils, we've been able to work out about processes that have taken place. Now, the geological timescale uses names which are mainly based on geographic areas and also some of the ancient tribes of Wales and of England. But there's one geological timescale which is based on fossils in Australia. And this is the earliest record we've got of complex life, the Ediacaran. And so we have a time period which is just after the Cryogenian, that's when the planet was covered with ice, which is the Australian time period. We've got a couple of American ones like Pennsylvanian and Mississippian, or in our part of the world, we call them Permian and Carboniferous. So this record of time is not only a record of time, it's a record of processes. What life lived, what life died, what catastrophes took place, what was happening, what was sea level doing, where we had volcanoes, what these volcanoes were doing. And so this geological timescale is international. I can be talking to someone in Bulgaria or Peru or Chad, and we're all talking the same language because it is an international timescale and it's based on data.
I think one of the things that confuses a lot of people is, why do we think climate shouldn't change? We can see from those sort of records that obviously climate change, I think, and the world's changing all the time. I mean, if you look at it, I think it's only about 20 million years since the Indian subcontinent rammed into Asia. It's only 20 million years ago since the Iberian Peninsula connected to France. So why would we expect the climate to be something that's just should be absolutely static for our human benefit?
Well, this is hubris, it's ego, it's narcissism, to believe that the planet is static, and once we come along, we are able to change a major planetary process. And climate is a major planetary process. It's probably driven by extraterrestrial processes like the sun and various galactic explosions, but also plate tectonics has a part in driving climate. So to think that the planet is static is the thinking of 500 years ago. And you mentioned the Iberian Peninsula. Now, we have sedimentary rocks on the floor of the Mediterranean that show that twice the Mediterranean evaporated and there were salt deposits left there. And that was because we closed off Gibraltar and joined it with Africa. It's a very dynamic process. And this process of plate tectonics took a very long time to work out. And the ideas were first proposed in about 1912. And these ideas were proposed by a glaciologist. And they were not accepted because the geologist said, oh no, what would a glaciologist know about geology? And the glaciologist used the literature to show that we had Permian, that's about 250 to 280 million year old material. We had Permian glacial rocks in Africa, in India, in Australia, in South America. We didn't know about Antarctica then. And the second thing is that when that Permian ice was moving across the ground, it held boulders stuck in the ice and scratched the ice. So you could work out the directions that the ice sheets flowed. And this gentleman put together the directions. And when he put them together, he was able to then say, oh, well, we must have had a supercontinent. And the ice sheets were radiating out from the center of this supercontinent, which later broke up. And then he started to look at the fossils in South America, in the literature, in Australia, in South Africa, in India, and then said, well, look, these fossil plants couldn't have swam or couldn't have walked across the land. The land must have been joined. And so this idea of continental drift came about just before the First World War. And he proposed a mechanism which was wrong, but he was absolutely pilloried, and pilloried for two reasons. Firstly, he was German, and secondly, that the mechanism didn't quite add up. And it wasn't until after the Second World War, and people started to come back to this idea. And they came back because in the Second World War, there was a brilliant idea to tow magnetometers behind ships to try to get the magnetic field of a submarine. And if you can find it, then you drop depth charges. Well, what they found was that there were stripes on the seafloor. And when we got down and drilled the seafloor, we found that these stripes were symmetrical around the mid-ocean ridge, and that the age changed as we went out from the mid-ocean ridge. And people went back to these ideas of Wegener in 1912 and said, well, yes, he was right. The continents did break up, the continents drifted, and now we have to get a mechanism to explain it. So scientific ideas take a very, very long period of time of testing, getting new data to evolve. The idea that humans will change climate is a very new idea. You can knock it out with geology very, very quickly, but that is not accepted because it's now become part of politics. And so I argue that the whole scientific concept of climate change, of humans driving climate change, is absolutely and totally invalid. It's certainly got nothing to do with the environment, because if you look at the damage that the climate mitigation effects do to the planet, they're just horrendous. And this is a political movement that hides behind pseudoscience. So we've seen this many, many times in the past. We've seen great scientific ideas get knocked out and then appear again. We once believed that we were the centre of the universe. We now know from measurement that we're not. We once believed that the sun rotated around the earth. We now know from measurement that it's not the case. We once believed that the atom was the smallest possible unit in the universe. That's not the case. We found subatomic particles. They were then counted as being the smallest things in the whole universe. And now we've found subatomic particles. So science keeps coming up with ideas which become the popular mantra, and some of them get knocked out. Now, climate change from day one was knocked out as being non-scientific rubbish, but it hasn't been accepted because it's been a great political movement where unelected elites can actually have power over you and can completely change our whole economy, and they claim it's based on science, which is settled. No science is settled.
Well, I suppose it all started with Dr. James Hansen back in 1988 when he fronted the Senate inquiry and put the proposition that greenhouse gases were warming the earth. And the thing is, I don't know if many people remember, probably up until about 2010 or so, if you Googled catastrophic global warming, if you put those initials in, you'd get thousands of hits on catastrophic global warming on the internet. Today, if you put in those letters, you come up with concerned concerned people for government waste or something. So catastrophic global warming has disappeared off the internet per se. But I also doubt if anyone or very few people even remember the hypothesis that was catastrophic global warming. Do you, off chance, remember what the hypothesis was?
Well, the hypothesis was that human emissions of carbon dioxide drive global warming. Now, there's a couple of problems with that. The first is that I have been pursuing scientists, and some of those at the Scott Polar Institute at Cambridge University. I've been pursuing one there. I sit on a board with one of Australia's former chief scientists, and I've asked them, can you please give me half a dozen scientific papers that demonstrate that human emissions drive global warming? That's never been done. And I've chased these people and chased them and chased them. I have never got scientific references to show that human emissions drive global warming. All we get are models based on pretty dodgy assumptions, but we don't get the data. So I argue from day one, this is a house of cards. And on the basis of that house of cards, we say, oh, we've got to stop human emissions. We've got to go towards net zero. So we build wind turbines and we get rid of perfectly good, cheap, reliable electricity that comes from coal-fired power stations. These wind turbines are made in China. Many of the parts use material that China absolutely totally controls. So what that means is that we're weakening our energy system and being reliant on China for our electricity. Wind turbines, for some strange reason, only operate when the wind blows. So they're unreliable. The only thing renewable about renewable energy is that the subsidies keep coming. They get renewed every year. It's your money, the taxpayers' money. But these will not generate electricity when you want it. And we have peak times when you use electricity. We need electricity 24/7 because supermarkets, for example, need to keep some of their foods cool overnight. We cannot have periods of low electricity. So if we look at solar power, it only gives us electricity when the sun's shining. And apart from that, we don't have electricity. So we have this massive imbalance now where we're substituting reliable, cheap energy with unreliable, expensive energy, where we are now dependent upon China. Now, in the case of the wind turbines, the blades are made out of balsa wood, so we have to clear fell a lot of the Brazilian rainforest to get that balsa wood. And there are various epoxies and resins used there, which use a chemical called bisphenol A. This is highly toxic. Most countries in the world have banned it, yet it's in the wind turbine blades. And when we have those blades spinning, they abrade and spread this stuff right over the countryside. And when the blade is ruined and it can't go on after a short life, we chop it up and put it in dumps in the soil. And this bisphenol A leaches into the waterways and into the soil. If we have solar panels, they're made in China, they're made by slave labour. They have toxins in those solar panels, cadmium, telluride, lead materials, and these slowly leach out from the solar panel onto the agricultural land where this solar farm has been built, and they stay in the soils forever. Again, they have a short life, and again, the life is even shorter if you have a hailstorm. And we've seen some of these in Texas totally wiped out by a hailstorm. So what we've done is, because we believed the mantra, we've been drinking the Kool-Aid, that human emissions of carbon dioxide drive global warming, we've changed our whole energy system. We've made ourselves dependent upon China. We've increased the cost of electricity. We've decreased the reliability of electricity. And whatever Australia does is not going to change the atmospheric carbon dioxide content, because China's emissions are increasing enormously. The second thing is, if by chance we did lower the atmospheric carbon dioxide content, then the oceans would exhale a little bit of carbon dioxide to put the atmosphere back into balance. So it's a totally, absolutely pointless task of trying to substitute unreliable energy with reliable energy and running up the average person's costs. But this is the movement that now is making huge amounts of money out of the average consumer, because our electricity networks and our generators are not owned by the public. They are owned by foreign corporations. They're using material from China. We have exposed ourselves to huge risk. And if you are really worried about this, do as I've done, is put in a generator at your house, because you're not going to be able to survive the future blackouts, and you won't survive your wallet being emptied.
Well, not only but energy security, it's actually national security that's threatened. Once you're depending on a supply chain to someone who's likely to be hostile to you, you're undermining your defence of your own country. But just going back to James Hansen, when he appeared to the Senate, his proposition was that for the CO2 increases, there would be a threefold increase in the amount of water vapour, and therefore you get what the effect of carbon dioxide was multiplied 3 times. That was basically the hypothesis of catastrophic global warming.
Well,
a lot of people don't realise that.
Hansen was wrong. What he didn't state was the main greenhouse gas is water vapour. It's not carbon dioxide. And the atmosphere's got far more water vapour in it than carbon dioxide. The second thing is that water vapour operates as a natural air conditioner. So when you evaporate water from, say, the Coral Sea and put it into rain clouds, you take energy from the ocean and put it into that water vapour. And when that water vapour then forms droplets and precipitates as rain, you then give out energy. The second thing is that water vapour actually tempers the atmosphere. So if you look at Townsville and Mount Isa, that are almost on the same latitude, then the temperature in Townsville is kept fairly mild by the high amount of water vapour in the air. It's humid in Townsville. So in summertime, the maximum temperature might be about 32 degrees, whereas at Mount Isa, the maximum summer temperature would be 45 degrees. Why? Because in Townsville, there's a lot of water vapour in the atmosphere, whereas at Mount Isa, there isn't. In wintertime, Mount Isa can get down to freezing point. It doesn't in Townsville. Why? Because of the water vapour in the air in Townsville. So Hansen was basically telling lies. He did not tell that Senate committee that the main greenhouse gas in the atmosphere is water vapour. It evaporates, and that's a heat process. It precipitates, and that's a heat process. That is the air conditioner in the atmosphere. And we move around that water vapour by wind and by currents of air. And that water vapour is controlled by the ocean temperature. So it's the oceans that drive the amount of water vapour in the atmosphere, and it's the oceans that drive the temperature of the atmosphere. And a good example of that is if you pour a bath, then the air in the bathroom heats up. If you do the inverse, pour a cold bath, and then run a radiator in that bathroom, then the water doesn't heat up. Water has a very, very high heat capacity. It is water and water vapour that drives the surface temperature. It isn't traces of a trace gas in the atmosphere. And that's what Hansen wanted us to believe, contrary to chemistry, contrary to physics, and contrary to what we know from the past. So he was telling lies to the Senate committee to get over his political view.
Not only that, Hansen was a very strong proponent for nuclear energy. And you would think the general census would be if his hypothesis was all compelling, that the natural flow would be from fossil fuels to nuclear energy. But I don't think anyone's thought that renewables were going to slot in between those two power sources. And it's probably thrown a spanner in the works from that transition from fossil to nuclear. But my concern now as we go forward, we're now having this narrative that we've got to go nuclear, but it's still the same old problem. If people are pushing nuclear, they continue to rely on the climate change or global warming side of it. So the people pushing nuclear will happily also promulgate the climate change and the dangers of carbon dioxide because it suits their narrative. How do you go back and get this debate back where it should be? Let's talk about really what carbon dioxide is doing and dismiss. Let's face it, it's plant food. Why can't we go back and have this debate and get it all back to square one?
Well, we'll never have a debate. We never had a debate on climate because there are too many snouts in the trough. You can make a fortune if you own a wind turbine. You can make a fortune if you own solar panels. And if you've got government mandates that make sure that you get paid if the wind's not blowing, you get paid if the wind's too strong, you've got to turn off the wind turbine, and you get subsidised, then there are so many people with a self-interest now, this is very, very hard to change. And I think the only way we'll get a change is to have real economic hardship, not the hardship that most people are undergoing now, but something even worse than that, such as a recession or a depression, and perhaps even a war. In this country, when you're off-grid, and we've had that for a long time, people have used solar and wind. Just go to any outback station. We have, especially in Queensland and New South Wales, huge amounts of really top quality coal, and that was used to generate very cheap, reliable electricity. In Victoria, we had thousands of years of brown coal. We've still got it. That, for a time, created the cheapest electricity in the world. We can't have much hydro because we don't have very high rainfall, and we don't have 4,000 metre high mountains to give us the head that we need for hydro. But we do have a little bit of hydro. We've got quite a bit of gas, which is a nice backup. We need gas, not so much for cooking and not so much for creating peak load electricity, but we need it for making fertilisers. We need it for making plastics. We need it for all sorts of industrial processes. And of course, we have had a nuclear reactor in this country for 70 years. We're on to our second nuclear reactor. And that's at Lucas Heights in Sydney. That's used to make medical isotopes. If you've ever had cancer, there's no way you can be anti-nuclear. So if you want to have a secure, safe country, the best way to do that is to have numerous sources of energy which are fit for purpose. And it's ridiculous to build a whole new grid system by generating wind and solar power right out in the donga, when in fact it's used by people living in industrial and city areas along the coast. This is where the power should be generated. Many, many other countries do this. When I lived in Munich, right in the centre of Munich, was a nuclear reactor. And that was reactor generated research, but it also generated electricity. If you look in many parts of the US, there are reactors in and at the edge of cities. 19 of the G20 countries have got nuclear power. The only one who doesn't is Australia, yet we produce a lot of uranium. So I think we've absolutely and totally blown our whole policy on energy. We have been listening to the carpetbaggers and the White Shoe Brigade. We've let these people in to dominate our energy system, and we the electorate, can only vote out a parliament, but that doesn't change our energy system. We've got to have a system where we basically are forced to go back to cheap, reliable energy. We're not there, and we're a long way from there.
Well, one of the strange things is up in our country area, if we want a dam, and we're never going to get a dam because we don't, most of the time, there's stringent criteria for cost benefit analysis. And the way they frame it is such that they want a return of the capital, which is in 30 years, which is ridiculous. I mean, dam's got a much bigger life than that. But the cost benefit analysis usually ends up costing the water at about $5,000 a megalitre. So no one wants to go farming with water costing you $5,000, so the dams don't get built. But renewables don't seem to have any cost benefit analysis done. And we're now looking down the barrel. I mean, a lot of people thought, oh yeah, we get a wind farm here and a solar farm there. But now people are starting to wake up to the scale of these things. It's not one here and one there. It's hundreds between Cairns and Port and Cape Otway. There's probably plans for about 500 different renewable projects in regards to solar and wind. That's a massive footprint, and I think people are starting to wake up at the impact on the environment from that, and we're also being affected by the cost. How hard do you think things have to get for people to really arc up and start vote out everyone who spills this stuff? Do we have to all go broke first?
Well, you've covered a couple of areas here. Firstly, with the dams, we haven't built a decent dam in Australia for a very, very long period of time. And we are always at the brink of a water shortage now in Australia, especially in the highly populated areas. And I'll give you the example of Sydney. When the Warragamba Dam was built between 1948 and 1960, there were 1.9 million people in Sydney, and no one lived on the floodplains below Warragamba Dam. Now there's 5.1 million people in Sydney, and every time Warragamba Dam overflows, the people on the floodplain complain. Now, if you build on a floodplain, it's called a floodplain for a bloody good reason. And so Sydney has put itself in a situation where they may well have huge water shortages the next time we have a drought. There just isn't the water. So I think that would be one of the triggers to build new dams. We've also seen triggers when we've had long periods of brownouts and blackouts. In the past, we've had triggers like blackouts that have people have said, well, no, forget it. We've got to get ourselves coal-fired power. So I think we've got to suffer some hardship before something happens. We have totally blown our policy on infrastructure in this country. Now, we're adding a large number of people to this country every year. I don't think many Australians did vote for that. And we don't have the infrastructure. We don't have the housing. We don't have the water. We don't have the sewage. We don't have the roads. We don't have the electricity for having such a large number of people come in. You cannot have 1 million people come in a year unless you've got the infrastructure to support these people. And that's what's happening. So you're very lucky living in FNQ, because most of the immigrants live in Sydney or Melbourne. God knows why. I mean, you'd be mad if you lived there, but they do, and they're suffering the infrastructure. And I think, yeah, well, yeah, thank heavens. And I think once the big cities start having problems with water and electricity, you will get a political change. But politically, people don't care about what happens in Queensland. You have very large electorates, like Bob Katter's electorate, for example, a very large electorate, and it covers a huge area, yet the same number of people live boxed in apartments and very small areas in Sydney, and they have the same power as someone living in Cloncurry, who might actually contribute to the economy of this country. So we are very, very much out of balance in this country, and the cities have to suffer before something will happen in rural Australia.
Just moving on now to plant food and the focus on mitigation of carbon dioxide. We're undergoing very expensive cost of living because of the fear of plant food, and we also have reasonably strange and expensive methods of getting rid of it. Now, carbon capture and storage has always been sort of on the books, and it's been tried out in a number of places, but it always seems to come unstuck because of costs or it being ineffective. We've now got a proposed project. Actually, I think it's actually got a tick, where Glencore is going to put its byproducts, carbon dioxide or plant food, which plants can sequester anyway, but they're going to pump it, take it. I think they're going to move it about 400 kilometres from where it's produced up to the old oil or gas fields in central Queensland, and then inject it into supposedly a layer of rock and that below the artesian basin. These things are expensive, but are they also a risk?
Well, there's a long story on this one, and it is that Glencore want to compress carbon dioxide, that's a waste product from a coal-fired power station, into liquid carbon dioxide. This requires about 20% of the energy that the coal-fired power station generates. And that liquid carbon dioxide is at very high pressure and it's at very low temperature. Then they want to transport that in tankers a couple of 100 kilometres up to Mooney and put it down a well into the precipice sandstone. Now, the precipice sandstone in the Great Artesian Basin is the main aquifer. It's the world's biggest freshwater or saline aquifer. The precipice sandstone in odd places does have a little bit of gas and oil in it. Now, we know to the west of the Great Artesian Basin that there are many areas where the precipice sandstone is leaking out that artesian water, and that gives us the mounds springs that you get in the western part of the Great Artesian Basin. And we know that in the eastern part of the Great Artesian Basin, the precipice sandstone comes to the surface. We know that the precipice sandstone is quite porous, and those pores are normally filled with water. So what Glencore want to do is to pump this liquid carbon dioxide into the precipice sandstone. Then you've got to really give it some pressure to push out the water along the sandstone and fill those pore spaces with liquid carbon dioxide, and hope to hell that it stays there. Now, what they haven't looked at is what happens in the western part of the Great Artesian Basin, where the precipice sandstone actually leaks and water comes up, fractures up, faults up, cracks in the rocks, and it comes to the surface. Carbon dioxide could easily do that. Now, at 2.5 kilometres depth, that carbon dioxide is at very, very high pressure. And liquid gases have a process called flashing. This is where you go instantaneously from a liquid to a gas. In the case of carbon dioxide, it expands 300 times its volume by going from a liquid to a gas. This is an explosion. That fractures rocks. We geologists love the natural environments where this has happened, because this is where you often find copper and gold. A good example of that is the hinterland to your studio in the Chillagoe area. We've had these natural gas explosions, and these gas volcanoes have got no lava in them, just a huge amount of gas, which is often very cold, but it breaks the rocks. So if you have all this liquid carbon dioxide, 300,000 tonnes of it, in the precipice sandstone, 2.5 kilometres depth, it is very, very high pressure. It will find a weakness, it work its way up that weakness. It will then start to expand, it will explode, and you will get a gas volcano. And you say, oh, well, this bloke hasn't got ice blocks in his drink. He's just talking rubbish. I'm sorry, folks. Some of you would remember in August 1986, and again in 1984, there were explosions of carbon dioxide out of lakes in Cameroon. And the best known one was Lake Nyos. And on a quiet night, when there was no wind around, we had a sudden loss of carbon dioxide from lake waters deep down. These cold lake waters released the carbon dioxide and went into the air. Carbon dioxide is heavier than air. There was no wind to disperse it or spread it around. That carbon dioxide pushed away the air. It stayed in the valley, and nearly 2,000 people asphyxiated. 3,500 stock died, and countless wildlife died. It's happened before. That process also happened in 1984. So that's exactly the scene that we're setting by putting liquid carbon dioxide into the precipice sandstone of the Great Artesian Basin. We're setting up an environment where gas could explode to the surface, could fill low-lying areas, and to kill people. Now, there are 180,000 people who live in central Queensland who rely on the Great Artesian Basin. And many of these towns are on rivers in low-lying areas. But we just put the carbon dioxide into the precipice sandstone and don't worry about it. Bob's your uncle. We don't have to worry about it. The other problem, which is well known, is that carbon dioxide reacts with water to produce carbonic acid. When that acid will dissolve some minerals in artesian basin sedimentary rocks, and we get arsenic, lead, and cadmium that go into solution. And these then come out in the irrigation waters, in the stock waters, and in the drinking waters. So this is an extraordinarily dangerous thing to do. There has been a bit of political pressure in the Senate, and Senator Roberts and Senator Hansen got agreement for the Senate to have an inquiry. And I have put in the submission. I think the guest you've got in issue number 133, Colin Boyce, the member for Flynn, he will have a lot to say on this, and I talked to Colin on it quite a bit. There is a lot of concern about it. So the Senate is having an inquiry into this, and I think the Queensland government has to make a decision in late May about it. With elections coming up, they'll probably quietly drop it and try to do it after the election. So this is what happens when you have politics driven by ideological fools where they don't look at the science. They don't consider people living in rural and outback areas where they just want to use their harebrained scheme to get rid of this gas of life and to sequester it into rocks and hope that the problem goes away. And we've been sequestering naturally carbon dioxide for 500 million years into plants, into shells, into skeletons, into limestones, into limey sediments. And we've gone from, over that 500 million year period, from 0.7% carbon dioxide in the atmosphere to 0.04%. The real problem is we don't have enough carbon dioxide to feed the planet's plants. We need more. The optimum level is about 1,000 parts per million, and just go and talk to any horticulturalist, they will pump carbon dioxide into their glasshouse to make the crops grow. And we see that with the very slight increase we've had in carbon dioxide in the atmosphere over the last 30 years, the satellite records show that we've had a slight greening of the planet. So carbon dioxide is not a poison. It is good for you and good for the plants. And this is a harebrained scheme to destroy the biggest aquifer in Australia. I think we should say no.
I think there's two issues there. Is why do we keep persisting with building things that are inefficient, or having processes that are inefficient? You've got to use more power to do something, and that's not available for the network or productivity. We always used to improve things so that they were more efficient, but this fear, this inane fear of carbon dioxide, has it made some people mad that they think inefficiency is the way to go?
We once had a country run by practical people. We now have a country where the bulk of the votes are in city people who haven't got a bloody clue about how the world works. They've never got calluses on their hand. They go into psychological meltdown if they break a fingernail. They've never gone for a week without having a wash. These people have no idea how the world works. Those people living in Sydney, they go to the wine fields at Mudgee and they think they're outback. Now, I can tell you, on a quiet night in Mudgee, you can hear the surf. It's only 200 kilometres inland. These people have no idea. Now, in previous generations, we all knew someone who had a farm or worked on a farm or worked in a mine or was living in a mining town. But that's not the case now. There are very few people that are the real producers of wealth in Australia. And that wealth comes from the soil, it comes from the rocks. And so our food and our fibre and our energy and our metals, people have no idea where they come from. They have no idea how these things are made. And what got me into being a geologist or into science was being curious. How do you make copper wire? I was making a crystal set. How do you make copper wire? And the teacher had to go back and learn a few things, but he then told me how you start with a rock and you mine it and you concentrate it and you smelt it and you refine it and you draw out wire, which is what happens in any copper refinery. And I thought, wow, this is superb. Kids have no idea about this today, and nor do their teachers.
Not only that, they're just confused who they are as well. But the other thing, moving away from rocks just to ice, because ice cores also provide us with a wealth of information, because, like you say, for the last 2 million years, we've been in an ice age, and we've fluctuated between glacial and interglacial periods. And when we go into glacial periods, and we're fortunate, we live in an interglacial period. I don't think people know how lucky they are. But that cores actually show us during those glacial periods, atmospheric carbon dioxide levels can get down to about 180 parts per million. Well, at 150 parts per million, our planet's in dire straits because it's not hardly enough to keep the plants going. And if they don't go, well, then the animals don't eat, and then we don't have any food to eat either.
Well, the good news about that is the vegans die out. Ice cores are quite fascinating because we have ice cores in Greenland ice sheet. We've got ice cores from Vostok in Antarctica. And by drilling through the ice, we can see into the past. We know where we are because there's certain volcanic dust and acid layers from eruptions, and we can measure when they occurred. And so we've got a measure of time going down that core. And in that ice core, we also see periods when it was very dusty. And when it was very dusty is normally when it's cold. We don't get deserts form in warm times. They actually form in cold times. And so we can see periods when we had deserts. We can actually, from the ice, measure the chemical fingerprints of the ice, and we can work out the temperature which that snow fell. Now, as the snow is falling, it traps air in the snow, then that gets compressed into ice. And so we have old air bubbles in the snow, and we can extract that air and measure the amount of carbon dioxide that is in ancient air. We know when it occurred from the volcanic ash layers, and we know what the temperatures were. So then we'd be able to calculate cycles where we see periods when it's very cold for about 90,000 years and then warmer for 10,000 years. But during that period of time, temperature is up and down like a yo-yo. And every time the temperature rises, we have an increase in carbon dioxide. Now, when we first did those measurements on the ice, the scale of measurement wasn't good enough. It is now good enough. And what we see is that every time you get a natural warming, later on, thousands of years later, you get an increase in carbon dioxide. So it's actually temperature that's driving the amount of carbon dioxide in the atmosphere. It's not the amount of carbon dioxide in the atmosphere driving temperature. So it's the inverse of what we're being told. And we should have worked that out anyway, because if human emissions, we're told, drive global warming, they're only 3% of the total. What about the other 97%? You've got to show that they don't drive global warming. So you've got a real problem in looking at ice cores because they don't give the story you want to hear. What the ice cores tell us is we've got natural warmings and coolings, and every time it warms, later on we get an increase in carbon dioxide. And that carbon dioxide dissolves in the oceans or then is exhaled from the oceans, depending upon the temperature. It is the oceans that are the lungs of the planet. It's not the Amazon. It's not human factories putting out carbon dioxide. So the ice cores, and the ice is a rock. It's a natural substance, which is crystalline. It's a rock. And ice is a very interesting substance because the ice in Greenland and the ice in Antarctica is actually in basins. The weight of the ice has pushed down the crust, and we get these big basins. So the ice actually flows uphill before then it flows downhill in glaciers and calves into the sea. So if we're getting global warming, how come ice is flowing uphill? It's got nothing to do with temperature. It's to do with pressure, squeezing the ice like toothpaste and making it flow uphill. And then when we look at that ice as it melts, to go from ice into water is a process of energy transfer. And we've got to be changing temperature to do that. What we also don't hear is what some of us might see in Iceland, but we don't hear about it in Antarctica. Underneath the West Antarctic ice sheet are 150 hotspots and active volcanoes. Ice might not melt due to air temperature. It may well melt due to volcanic activity beneath the ice. We see that happening in Iceland. We suspect it's a major process that takes place in Antarctica. You never hear about it. Why not? Because it doesn't fit the narrative.
Well, that seems to be the problem. They control the narrative at the moment, and common sense and real hard science and the scientific method is not getting a fair hearing.
No, well, that's right. And that's why I say that climate science isn't science. It's political propaganda. It's unrelated to science because it doesn't fulfill the criteria of the scientific method. And that is that if you've got one shred of evidence that is against the theory, you have to abandon the theory. What happens is if I present that one shred of evidence, I get abused and pilloried rather than people saying, well, that's interesting. Let's go back to the drawing board and have a look at our theory. So it's not science at all. It's a mechanism of unelected people somewhere probably in the IPCC and UN, having control over you, your money and your life, whether you can fly here, whether you can use a diesel, whether you can actually heat your house, whether you can use air conditioning. This has got nothing to do with science. This is all about unelected people having control over you and your wallet.
And a lot of people making a lot of money out of it.
Oh, look, follow the money. I mean, why do you think all the white shoe brigade's gone into renewables? And I won't mention any names because they've got more money than me, but you know who I'm talking about.
But the thing is, it always comes on the basis of they won't start a project until they've got a grant and a guaranteed ongoing subsidy.
Well, you got to remember those grants are our tax money, and you got to remember the people who are distributing the tax money are people we vote in. So we do have a little bit of power, and I think with your forthcoming election in Queensland and the forthcoming federal election, whatever that might be, I think we've got to think very carefully about who we vote for.
Yeah, well, everyone pushing the narrative of catastrophic global warming or energy
Put them at
transition
the end.
and net zero down the bottom.
Yeah, yep, down the bottom.
Okay,
yep.
Okay. We've done the hour pretty easy. I'd just like to thank you for coming on. I'll just give you a last wrap up in regards to what you're doing over the next few days or weeks in regards to conferences or town hall meetings or anything else you're doing, lectures. So if you give the viewers a bit of an idea of what your sort of schedule is for the next few weeks and your peaks of interest.
Well, I have a very feral life. You're the third interview today. I've got another one that in about 2 hours' time. I've got another one at 8 o'clock tomorrow morning. And then I've got one at 10 in the morning. Then I drive to Broken Hill. I'll be underground on Friday, come back Friday night, be home Saturday. Sunday, I go across to Melbourne. The reason I'm in Melbourne is that I have a pretty aggressive metastatic melanoma. It's got into the brain and in the lungs. It's under control. I go there for a grease and oil every 2 months or so. So I'm going to Melbourne for cancer clinic grease and oil. I'll be there for a few days. Then I'm back, and then it's more the same. So I'm in full-time work. I'm flat out pushing what I believe is an absolute error that's happened in our politics, and that is our climate policy. I don't want to see my kids or grandkids end up being absolutely destroyed economically. My agenda is very simple. Get out there and tell the truth. If you tell the truth, you never have to remember what you said.
That's so true. Okay, if you could just stay on the line, I'll just introduce next week's guest and then just have a quick chat, if that's okay with you. And again, thanks very much for coming on.
Thank you for having me.
Thank you. If you enjoyed tonight's show, please like, share, and join and subscribe to our Facebook page and join our YouTube channel. Next week, I'll have a break for a family event, but I'll be back the following week on the 29th, and my guest will be Colin Boyce. And we'll be following on from the topic we just touched on, the Glencore project to inject carbon dioxide into the Great Artesian Basin and its effect on rural and local communities of central Queensland. So please join me on the 29th, and Colin Boyce, the member for Flynn, will be my guest. Thank you.